Hello everyone. In this video we are going to learn how to determine the amplitude, wavelength, period, frequency and the speed of the wave if we are given the following wave. So let us first try to see what is given to us. We are given now the distance of 4 meters, but this distance is from the below point of the wave to the upper point of the wave. Then we are also given the distance of 6 meters, which is the distance from the starting point of the wave to the last point of the wave. And we also have the times at these 2 points. So the first question says we must determine the amplitude of the wave. So we know the amplitude is the distance from the zero line to the minimum point, or from the zero line to the maximum point. But in this case, what is given to us is the distance from the maximum point to the minimum point. So to determine the amplitude, that means we must divide this distance by 2 so that we can get the amplitude. So if we divide 4 by 2, that will be 2 meters here, and then also this will be 2 meters there. And then remember that indicates the amplitude. So the amplitude to this problem is just going to be 2 meters. So now when we talk about the wavelength, we also need to understand what is a wavelength. So a wavelength is a distance it takes to complete one wave. And then remember, to complete one wave, we need to complete 1 second. So if you look at our wave here, from the starting point here, we are going to complete half of a circle and the other half of a circle. So at this point, we have one wave since we have completed full circle. So this will mean the distance from this point up until where we finish the complete circle is going to be a wavelength. Then we can also see again we have another wave which is complete. So therefore we also have another wavelength. So do you see now this distance of 6 meters is equivalent to 2 wavelengths because it's the total length of 2 waves. So now to identify or give the value of the wavelength, we are going to say what? 2 waves are equal to what? To 6 meters. So to determine the wavelength of one wave, we're going to divide both sides by 2 and get that the wavelength is 3 meters, which is going to be 3 meters here and 3 meters here. So when we add them together, they're going to give us the total distance. So number C says we must determine the period. And we know that the period is the time it takes to complete one wave. So remember, we completed one wave when we get to this point here. So this means the period is 1.5 seconds. The period is not the total time. It's just the time it takes to complete one wave. So the period will be equivalent to 1.5 seconds. So up to here, we just was able to identify all this by doing the analysis. So when we determine the frequency and the speed, we need to do some calculations. But now there will be formula sheets that are given to you so that you are able to determine the following. So when they say that you must determine a frequency and you have a period, so the frequency equation is 1 over period. So to determine the frequency, you just substitute 1 over period. So we already know that the period here is 1.5. And therefore, the frequency will be 1 divided by 1.5, which is the same thing as 0.67 hertz. So the units for frequency is hertz. So that is how you will calculate the frequency. So the last question that we have, they say we must determine the speed of the wave. So now the speed of the wave, or the speed of anything, is given by the following equation. Speed is equal to distance over time. So now if we have the total distance of the wave and the total time of the wave, we are able to determine the speed. But now we must use the total distance and the total time. So we're going to say, okay, the total distance of this whole wave is 6 and the total time is 3. So therefore, the velocity or the speed of this wave is going to be 6 divided by 3, which is 2 meters per second. But there is another thing that we can use, which is the very same thing as the equation of the speed. The equation of the speed can also be described as the wavelength divided by the period. So if you have the wavelength and you have the period, you can determine the speed of the wave. So we have already calculated the wavelength and the period. So that means we can substitute here the wavelength of 3 and the period of 1.5. And we are going to get the very same velocity of 2 meters per second. So that is all for this video. Thank you very much.